Number 1, f of x is equals to log base 5 of x plus 2. Our domain is x is greater than 0. We have 0 and positive infinity. Our range is constant. We have negative infinity, infinity. For our vertical asymptote, we have x is equals to 0, which we can say in our domain. There is no horizontal asymptote because logarithmic function is inverse to exponential functions, which has no vertical asymptotes. For our x-intercepts, we let y is equals to 0. We come up with 1 over 25, 0. There is no y because it won't cross y-axis. And for our zeros, we can see it in our x-intercept, or we let y equals to 0, we have 1 over 25. For the table of values, we substitute our x values to the equation and we come up with this. As you can see in our graph, there is a vertical translation. So the transformation would be the graph of f of x equals to log base 5 x plus 2 shifts the graph of g of x equals log base 5 of x 2 units upward. Number 2, f of x is equals to log base 4 of quantity x plus 3. Our domain would be x is greater than negative 3. So our domain would be negative 3, positive infinity. Our range is constant, negative infinity, positive infinity. For our vertical asymptote, we have x is equals to negative 3, which we can also see in our domain. Our x-intercept, we let y is equals to 0. We have negative 2, 0. And there is a y-intercept, which is at 0, 0.79. And our zeros, we can see it in our x-intercept, or we let y is equals to 0, so we come up with negative 2. In our graph, there is a horizontal translation. So these are our table of values. In our table of values, we substitute our x values to our equations, and then we plot the values. And the transformation of the graph of f of x is equals to log base 4 quantity x plus 3 shifts the graph of g of x equals log base 4 of x 3 units to the left. For number 3, f of x is equals to negative log 5 of x is greater than 0. Since there are no changes, it is just a reflection, so our domain is the nearest value of 0 to positive infinity. And for the range, which is constant, we have negative infinity to positive infinity. For our vertical asymptote, we come up with x is equals to 0 since we have our vertical asymptote at the y-axis. And for the x-intercept, we let y is equals to 0. We come up with 1, 0, same as our zeros. To find the zeros, let y is equals to 0. We come up with 1, or we can simply see it in our x-intercept. Since the reflection is about on the x-axis, there are no changes for x-intercepts and zeros. They are both the same at 1. Then, for our tables of values, we substitute our x values to our equation, and then we plot to come up with a graph. In this function, we have a negative beside our logarithm. So in this case, there is a reflection about x-axis. Thus, the graph of f of x equals negative logarithm base 5 of x reflects the graph of its parent function, g of x is equals to logarithm base 5 of x about the x-axis.
Number 4, f of x equals to logarithm with the base of 4 quantity negative x. The transformation of the graph of f of x equals to logarithm with the base of 4 quantity negative x reflects the graph of f of x equals to logarithm with the base of 4 of x about the y-axis because of quantity negative x. Identify the following. Let's start with intercepts. It has no y-intercept because of the location of our vertical asymptote. For our x-intercept, it is equals to negative 1, or shown here in our solution. For the zeros, we can refer to our table of values. We can find here 0, and our zeros is x equals to negative 1. Our asymptote, vertical asymptote, is at the y-axis, or x is equals to 0. For our domain, it is negative infinity to nearest values of 0. And for logarithmic functions, range remains constant at negative infinity to positive infinity.
Number 5, 3 log base 5 of x. Now let's find its characteristics. First, the zeros. So you equate your equation to 0, so we have x is equals to 5 to the power of 0, which is equals to 1. For our asymptote, equate your x to 0, so we have x is equals to 0. And for our x-intercepts, let your y be 0, so we have x is equals to 5 to the power of 0, which is equals to 1. And we have the value 1, 0. And for our y-intercept, there's no y-intercept since our argument is less than 0. And for our domain, you set your x greater than 0, so we have 0 and positive infinity. And for our range, it has a constant value, which is negative infinity to positive infinity. And in graphing, we plot all the values of the points in x, f of x, and u of x. Therefore, the graph f of x, 3 log base 5 of x, stretches the graph since c is greater to 1.
Number 6, f of x equals to negative logarithm with a base of 8 of x minus 3. The transformation of the graph of f of x equals to negative logarithm with the base of 8 of x minus 3 reflects the graph of f of x equals to logarithm with the base of 8 of x about the x-axis, since negative is beside logarithm and 3 units downward because of x minus 3. Identify the following. Let's start with intercepts. It has no y-intercept because of the location of our vertical asymptotes. And for our x-intercept and zeros, it could be there is x-intercept and zeros, or we can solve it, which is shown here. So our x-intercept is equals to x equals to 512, and our zeros is at 512. Asymptotes. Vertical asymptote is at y-axis, so x is equals to 0. And for our domain, x should be greater than 0, or 0 nearest values of zeros to positive infinity. And for our range, which remains constant, is at negative infinity to positive infinity.
Number 7. The function is f of x equals to 7 multiplied to logarithm base 3 of negative x. The graph is shown. The graph of f of x equals to 7 multiplied to logarithm base 3 of negative x reflects the graph of g of x equals to logarithm base 3 of x along the y-axis and stretches the graph since c is greater than 1. And for the asymptote of the function, the argument is negative x. Just equate the argument to 0. Negative x equals to 0, divide both sides by negative 1, that will be x equals to 0. So that will be our asymptote, x equals to 0. And for the zeros or the roots of the functions, just change f of x to 0. So that will be 0 is equals to 7 multiplied to logarithm base 3 of negative x, divide both sides with 7. After that, transform the logarithm function into an exponential function. That will be 3 to the power of 0 is equals to negative x. 3 to the power of 0, that will be 1. Negative x equals to 1, divide both sides by negative 1, that will be x equals to negative 1 for our zeros. Automatically, our x-intercept is equals to negative 1, 0. And for the y-intercept, there will be none, since our asymptote lies at the y-axis. The table of value is shown. From the table of value, we can conclude that the domain of the function is from negative infinity to 0. And our range of the function is from 0 to positive infinity. Number 8. F of x equals to negative 9 plus logarithm base 8 of x. The graph is shown. The graph of f of x equals to negative 9 plus logarithm base 8 of x shifts the graph of g of x is equals to logarithm base 8 of x 9 units downward. For the asymptote of the function, just equate the argument, which is x, to 0. That will be x equals to 0, so that will be our asymptote, x equals 0. To find the roots of the function, just change f of x to 0. That will be 0 is equals to negative 9 plus logarithm base 8 of x. Add 9 to both sides of the equation, that will be 9 is equals to logarithm base 8 of x. Transform the logarithmic function into an exponential function, that will be 8 to the power of 9 is equals to x. Therefore, x equals to 134,217,728. Automatically, our x-intercept will be 134,217,728, 0. And there will be no y-intercept because our asymptote belongs to or lies on the y-axis, which is x equals to 0. And this will be our table of values. From the table of values, we can conclude that our domain or the domain of the function is 0, positive infinity, and the range of the function is negative 9, positive infinity.
So number 9, f of x is equals to log base 2 of x plus 1. So first, let's find the value of its 0. So equate your equation to 0. So we have 0 is equals to log base 2 of x plus 1. And then apply the property of logarithmic function. So we have 2 to the power of 0 is equals to x plus 1. And then simplify further. So we have x is equals to 1 minus 1. And then x is equals to 0. For the asymptote, we equate our x to 0. So we have x plus 1. And then apply the property of equality. So we have x is equals to negative 1. For the x-intercept, let your y be 0. So we have 0 is equals to log base 2 of x plus 1. And then we simplify it further, use the property of logarithmic function. So we have the final values 0 and 0. For the y-intercept, let your x be 0. So we have the y is equals to log base 2 of 0 plus 1. And then we simplify it further. So we have the y is equals to log base 2 of 1. And we know that the value of log base 2 of 1 is just equals to 0. So we have the values 0 and 0. For our domain, we set your x greater than 0. So x plus 1 greater than 0. So apply the property of equality. So we have the x is equals to negative 1. Therefore, for our domain, it's equals to negative 1 to positive infinity. For our range, we have the constant value, which is negative infinity to positive infinity. For graphing, we plot all the values shown in the table of values. And then as we can see in the graph, we can conclude that there is a horizontal translation in the equation f of x is equals to log base 2 of x plus 1. Thus, it shifts the graph of g of x is equals to log base 2 of x 1 unit to the left.
Number 10. F of x is equals to 9 logarithm base 5 of x. The graph is shown. The graph of f of x equals to 9 multiplied to logarithm base 5 of x stretches the graph g of x equals to logarithm base 5 of x since c is greater than 1. For the asymptote, just equate the argument to 0, which is x equals to 0, so that will be our asymptote. And for solving the zeros or the roots of the function, transform or change f of x to 0. That will be 0 is equals to 9 multiplied to logarithm base 5 of x and divide both sides by 9. So that will be 0 is equals to logarithm base 5 of x, and then change the logarithmic function into an exponential function. That will be that will be 5 to the power of 0 is equals to x. So x is equal to 1. So automatically our x-intercept will be 1, 0, and there will be no y-intercept because our asymptote belongs or lies onto the y-axis, or x equals to 0. And for our table of values is shown above. Based from our table of values, the domain of our function is 0 to positive infinity, and our range of our function is 0 to positive